Okay, so what we're looking at with this is how to read two charts from your reference tables on page 15. The characteristics of stars chart and the solar system data chart. All right, so if you look at stars, there's really two things that really stick out about them that you should notice. That some stars are brighter than other stars, and some stars are different colors than other stars. So using those two characteristics of stars, they can be plotted on this graph. Luminosity is how bright a star is. And what these numbers mean is how bright it is compared to the sun. So because the sun is the star we're most familiar with, they gave a sun the brightness of 1. So 10 means 10 times brighter than the sun, 100 times brighter than the sun, 1,000 times brighter than the sun. 1/10 as bright as the sun, 1/100th as bright as the sun, and so forth. So that's what luminosity is. As far as the color, the reason why stars have different colors is they have different temperatures. So red stars have a temperature around 2,800, orange are around 3,500, yellow around 5,000, white around 8,000, blue and bluish white around 20,000, and so forth. So the color tells us the temperature. And if you make the observations about the stars' temperatures and colors and plot them on this chart, what we'll find is that most stars plot in this section right here called the main sequence. All right? The main sequence is the early stage of star development. All right? This is where most stars fall in the main sequence. All right? Now, as stars age, they don't stay in one spot forever on here. As stars age, where they would fall on the chart varies, would change, because as stars get older and they start to cool down, they start to get bigger, and then they turn into giant stars. So these are the giants up here. And then, so it says intermediate stage. And then when the giants get old, they shrink down and become hotter, and they turn into a white dwarf. So it would move down here. It says white dwarfs, the late stage stars. So like white dwarfs, they're fairly hot, but they're not very bright. Where giants are fairly cool, but they are very bright. All right. Also over here, it tells you the mass of the stars. So the stars up here are very massive, while the stars down here are very small. All right. So that's how you read that chart. It's fairly easy. Oh, and also these little circles with the crosses in them, that's a particular star. So that's like the star Polaris, that's where it falls on this chart. The sun, that's where it falls on the chart. Betelgeuse, that's where it falls on this chart. That's the ones with the circles and the crosses are very specific stars. All right. The other chart I want to go over is a solar system data chart. This is a pretty easy one. It has various members of our solar system, the sun, the 8 planets, and Earth's moon. Here it has how far away you are from the sun in millions of kilometers. Period of revolution, that is how much time it takes to go around the sun is revolution. Notice here that some of these are in days and some of these are in years. And also notice that the planets that are closest to the sun take the least amount of time to go around the sun. The farther out you go, the more time it takes to go around the sun. Because the farther out you go, a couple things. One, it travels a bigger distance, and two, they go slower the farther they go out too. Next, period of rotation. That is like spinning on its axis. And again, you want to be careful when you look comparing these, because some of these are in days, some of these are in hours and minutes. A couple things to point out. One, Mars and the Earth, the amount of time it takes to spin on its axis are very similar, only about a half hour different. So Martian day is pretty similar to an Earth day. Another thing that's kind of interesting about this is if you look at the period of rotation of Venus and the period of revolution of Venus, is it takes 243 days to spin on its axis, it takes 222 days to go around the sun. So it's kind of interesting about that. That would mean that a Venetian day is longer than a Venetian year. Interesting. The next column over talks about eccentricity of orbit. That tells you the shape of the orbit. The closer that number is to 0, the more circular the orbit is. Equatorial diameter. So you can notice that Earth and Venus have a very similar equatorial diameter. But the main thing to notice is that the interior terrestrial planets have smaller diameters, while the exterior Jovian planets have larger diameters. The mass, so what they did here is they gave the Earth a mass of 1, and then all these other, you're just comparing it to the Earth. Like Jupiter has 317 times the mass of the Earth, or Venus is 0.82 the mass of the Earth. So that's what that means. And lastly here, density. So notice again the interior planets, Mercury, Venus, Earth, and Mars. They have pretty high densities when you compare it to the Jovian planets. And the reason being is these planets are rocky planets, those planets are gas planets. So gas is less dense than rocky material. Remember, if you get questions like, what planet has the shortest period of revolution, and you're like, oh, 27 days, it's the lowest of any of those. Yeah, but that's for the moon. The moon's not considered a planet. So remember that when you're looking up stuff, that the sun's not a planet, nor is the moon a planet, but they are parts of our solar system. And that is pretty much it for that chart.